another way? Stephen?
I just have a quick question. So what is identity? Because last year we learned that identity was the same line.
The identity
Infinite number of solutions because identity and dependent.
Then you check me.
No, that's Mr. Kelly taught us identity. Identity?
Yeah.
You know what, I don't remember. I'd have to look that up. I, off the top of my head, I don't remember that as an identity. And I can think of another identity, but I'm not sure it's the same thing. Stephen, can I get back to you on that? Okay. All right, so in this particular problem, let's think about the information that they've given us and how we want to go about solving this. We are starting with, so we're looking at this woman who is running a marathon. Before starting the marathon, she ate a 400-calorie meal. During the marathon, she eats an 8-calorie orange slice every 30 minutes, and she's burning 13 calories per minute. Okay, so we have, what do we have? We have input and we have what? Output. So one way of thinking about that is, what is she burning? How much is she burning?
1300 calories
per minute. So is the calories going to be a positive or a negative slope? Just think about it. Yeah. So we could have y equals a negative, I'm going to write here, I wasn't going to do this here. I'll do this here. I could have y is equal to 13x, okay, and it's decreasing. What about, what is she taking in?
8 hours.
8 calories every 30 minutes. And this is where you need to be careful. This one was 13 calories per what? Per minute. So this one was per minute. And then I gave you the information about eating the orange slice as how many calories every 30 minutes? 8. So wouldn't we want to be comparing minutes and minutes as opposed to minutes and 30 minutes? So if it's 8 calories in 30 minutes, can I figure out what that would be in 1 minute? And I think it was, what? 0.2665.
Yeah, I thought she was eating a slice every minute, so it kind of messed me up.
I guess so, yeah. It's 1 slice every 30 minutes, right? So it'd be 0.66x. And how much did she have? 400. So this is what's in her input. And then we're looking for the point where what happens? Where they intersect. Okay, that was one way of doing it. Okay, anybody else do it differently?
I have a question.
Yeah?
I don't believe I had it as negative 13. So how can I actually answer?
And she's putting in, she's burning 13 calories. I don't know, we'll graph it. Let's see what happens. What?
I just divided 400 by 13 and then 8 by 30.
Okay, say that again.
I divided 400 by 13. To get
400 by 13, okay.
To get the amount of minutes to burn out 400 calories and then 8 by 30, which is what you did, and then I added it.
And then you added the two?
So once you have that, how do you figure out how long it is?
Well, let me see. I did it, we could do it that we would see where the points of intersection were.
Alright, so you could use your calculator
Yeah.
for those 2 lines.
Yeah, and where the point of intersection is. What I did was, when I thought about this, I thought, let's see. She had 13 calories. I did it slightly different. I looked at it as, I'm going to close the shade.
I don't know what this year had.
Serial killer.
Yeah, serial killers all under our page. Magic princesses.
Okay, I looked at this as 13 calories per minute, that she was burning it, And I knew that I did my 8 divided by 30, and I got 0.266. So I know that she was burning it at a negative 12.733 per minute. And she was adding, she had the 400. And then what I did was I looked for when would it be 0? When did she use?
So you could just do 400 divided by 12.733, right? Because if she's burning that every minute and she starts
Yeah.
off at 400.
Yeah.
Where'd you get the 12.753?
Pardon me, how did I get the negative 12.73?
Yeah.
I knew that she was burning 13 calories per minute.
Yep.
She was taking in, the orange slice was 8 calories per 30 minutes.
So you just minus
So
that.
I divided 8 by 30 to get the 0.266, and I found the difference. So I knew that she was burning at negative 12.733 plus 400. What?
Aaron?
Is there a way on your calculator to find like the exact point of intersection? Because when I did second table 5, it puts the little track thing like down here, and then when you move it up, it like never gets to the exact point on it.
That's a really good question. And that's what we're going to be doing today, actually.
Oh, okay.
The calculator will not always give you an exact answer, and it's not the most precise answer. So we're going to do algebraic solutions, and the algebraic solution will give you an exact answer. That was a perfect segue, actually. Okay, so other than number 14, anybody else have any questions? You okay? All right. So what I'd like you to do is I'd like you to take out your notes again, and I'm going to try and keep you really organized. So just that note sheet, let's just continue on there.
Yesterday I was driving. You should be.
Everybody has their
I feel like I'm not friends for everybody. What?
Okay.
I don't even know. I'm so weird.
All right, you do not need to write this down, but we're going
Like I was tempted to do this.
We're going to be looking at 2 other ways. I trust that this is review for you, so that we're just going to do like a flyby, okay? And one of the ways to solve if you have a system, remember we're talking about a system, more than one equation, we have 2 equations, we're looking for perhaps the point of intersection we're trying to solve, and one of them is by substitution. So substitution is, the goal is to reduce the number of variables in one equation by substituting for the other variable. Okay, that's the definition, you're substituting. You guys do that when you play sports all the time. You take one person in and you put another one out. Okay, so in this particular case, it's substitution. It's a substitution. The goal is to reduce the number of variables in one equation by substituting for the other variable. And here's an example. Okay, I have a system, and you need to know, first of all, that this only works when you have a system. And I know that y is equal to 2x, and y is equal to 3x minus 2. Can I substitute? Can I reduce the number of variables? How many variables do I have in that equation? Each one. I have 2. I can't solve them unless I substitute one in. So how would you go about doing this? You guys all should remember this. Michael?
Subtract the 2x from the other equation.
I'm substituting.
Wait,
Jocelyn?
what is the y equals, what do they say?
I can't hear you, honey. What?
Yeah,
Does y equal 2x and this y equals 3x minus 2? Can I say, well, y equals 2x, I'm plucking it in and I'm dropping it in. That's what we mean by substitution. Yes? Okay, so all I've done is I'm going to just say, well, I'm going to just drop it in. Y is equal to 2x, well, I'm going to take this y out, and I'm dropping in a 2x.
For some of the problems, I did that last night, and it ended up being like 0.5x is equal to 20x or something like that.
I didn't give you any substitution.
I know, but
problem.
for some of them to double check my graphs,
I
I
see.
use substitution.
And so when you did the substitution, you didn't get the exact answer, is that what you're saying?
No, it ended up being really weird.
Okay. Let's talk about some really weird situations, because I think I can anticipate some really weird situations. Okay, so is everybody clear on the substitution?
Then I guess you just,
Okay, so at this point, I know that I have 2x is equal to 3x minus 2. Can I solve for x?
yeah,
Okay, remember, we are solving. What does solve mean?
X and a Y.
An x and a y. Lots of people think, aha, I got the x. So they know that I'm going to do what? Minus 3x, minus 3x, minus 1x is equal to a negative 2.
So
So
that's
what
equal
is
to
x going to equal?
2.
Positive 2. Are you done?
Nope.
No, what do you have to remember to do? You have to remember to find
So 2,
y.
sure. Why is it a
Okay?
4?
Common mistake. People think they're done. They need to continue. So you're gonna go back to your original. Easy to do this. Y is equal to 2x. Well, if x is 2, I know that y is going to be 4. Okay, and I should be able.
Wait, I don't get that.
2 times
I
2.
just solved for x.
Oh, I
X
get it,
is
I get
2. I go back to my original, and I should be able, I have to solve for y. Because remember, solving means x and y. Okay? Yes, no, maybe? Does that ring a bell? Everybody good?
Ringing a bell.
Okay, ringing a bell, good. Okay, what I'd like you to do is, if you need to make a notation, that's what you should do right now, remember. Okay, so you're taking notes, what do you need to remember to do?
Substitute.
Solve for y. So when you study